Yeah. I'm kind of surprised that I noticed actually.
Yeah.
Poor Amin. Can you imagine if that happened at your house?
I've been so happy.
Wait, we
I'm
can do a real fire drill.
Interestingly, students have done that before, and it was shockingly anticlimactic.
like, I've fucked up every year somehow. The first day of school, at my freshman year, I broke a window. I didn't know that the windows were locked, so my hand went through the window, and I just had glass all over me. That was Mr. Parsons' room.
Don't you all wish that you could keep Amin with you forever? Like, wherever I go in life, please come with me. If I could choose a pet, it would be Amin.
There's that dog that, like, gets hit by cars.
Kind of tragic, but kind of cute anyway.
I left the lights on.
Fun fact, speaking of making mistakes when you're in school, I was lecturing earlier and out of the corner of my eyes, I saw a person walk by whose costume was, I believe, a reindeer or something. And this person had like antlers. And because I was like focusing on the class, just out of the corner of my eye, I saw the antlers against the skyline. My first impulse as a hunter was to like shoot that thing. And so I was like, and then like the antlers disappeared behind the one window that is closed. And so in my head, I just went straight into like hunt mode. I was like, oh, human. Hold on. So talk about messing up, like. Yeah. We all make mistakes, I mean. Alright. Getting back to our assignment. Remember that Liebig's thing was always to fill in whichever minimum was the biggest weakness in the soil, demand-based. And I told you, please look up. This is the opposite of our more sustainable option, which is just ecological soil management to maintain the soil food web. Soil food web is magic. One good handful of good quality soil has more than 1 trillion with a T individual bacteria and many thousands of protozoans, nematodes. It has miles and miles and miles and miles, like 15, 17 miles of mycorrhiza, the little fibers that that mushrooms use to eat from the dirt, all in a handful. So think about all that aggressive chasing and hunting and eating. I want to use a metaphor. Whenever I had parties at my house, my dogs would get super excited. Because with all that activity at the table, with people like eating and dropping crumbs, my dogs would feast. Some jackass bumps a cheeseburger off the table, and my dogs are like, yeah, cheeseburger on the floor. And little chip crumbs and stuff, my dogs would be so excited. Y'all ever seen that? Like when dogs are super stoked, people drop a lot of stuff on the ground? Okay, now imagine the soil food web. All those decomposers taking big macromolecules and breaking them up into smaller nutrients. Ecological activity is like the party that feeds the dogs.
It's still really cold.
Here's the mystery. My students have found a way to start the microwave that's not like, and so they'll run it for like 20 minutes and it won't heat up. How did you start the timer? I'm just curious.
Time, 3 minutes.
Ah, yes. Put that thing back in there. Close the door. And now look at the bottom right. So here's a start. No, bottom right.
Oh,
Yep.
yeah.
Press that. And press it again. And again. Equal the opposite. Okay.
That's going to be really hard because there's so kind of long. I'll put it on for 2 minutes.
Okay, buddy.
Oh, no, it's a 420.
Oh.
There we go.
Can't have that. Can't have that. So you got your horizons, your soil, food web. The important thing for you to realize is all that magic, all that decomposition, and all that biological activity happens in the organic litter at the top and the topsoil below it, the O and the A. That's where the humus is, which is not humus. Did we talk about this last week? Humus is the organic material that's partially decomposed. That's where the party's happening for all the plants to get all their nutrient breadcrumbs. I hope you like my analogy. Number 18. You've already heard about the Dust Bowl. You know that erosion is bad. Erosion is two different problems. Erosion is the loss of soil where you need it, and the accumulation of sediment where you don't need it. Two problems. And how can we avoid? That's the wrong question number. This is number 18, not 23. Typo. Feinberg, please stand up. Everybody please imagine that Feinberg over there is the high point on a farm. Like that little high point right there. He's the top of the hill. If I am, why do farmers till the soil, by the way? Break it up and be fine. Why? Yes?
So that water can easily
That's right, it absorbs water better. Why else?
It aerates it.
It aerates it better. That's right, and plants need to breathe. What else? It's easier to shape. It's easier to plant. It's easier to pull weeds out of. It's easier to harvest. Everybody understand that? Farmers like their soil to be nice and fluffy and soft. Thanks, homie. I knew you could do it. Bravo. Now, farmers like to till their soil. It's easier to work on. Everybody has to understand that. The benefit of tillage. But imagine that homeboy is the top of the hill. So I'm like, tilling in a grid, tilling in a grid, tilling in a grid, tilling in a grid, tilling in a grid. And when that grid takes me straight over the top of the hill, I just push my tractor up the hill, and then I ride my tractor down the other side of the hill. Everybody got that? What's going to happen when it rains?
It's gonna water.
Right. It's going to roll. Yeah. Because if I just push my tractor straight up the hill, I've built like a weakness in the soil with like the ruts of the wheels and like the soft spot in the dirt, where like that water is going to snowball when it rains. Right? Everybody understand that? So conventional grid tillage increases erosion. And almost every farmer does that because it's simpler, it's more convenient, and it's cheaper. Think about it. But if you wanted to avoid erosion because you're afraid of the Dust Bowl or whatever, which you should be, then check it out. You can actually go around it on the gradient like this. Stand up again. I changed my mind, sorry. I go like this, and I'm standing on one elevation. Then I turn around my tractor and I'm a little bit higher, making a contour map. Don't know what contour maps are? Like you ever seen a topographical map? Or like an ocean bottom sea chart? So I just till on the contours, which is very time consuming. It's a little more expensive. Sometimes they use like fancy technologies which cost much dollars. But you can see there, it sets up like shelves. So the water, instead of like gushing down, sort of like slows at a tractor tire gutter, and then it slows at the next level, and it slows at the next level. You know, it's like micro terracing, sort of. Yes, contour plowing. Also, what if you could just learn different sorts of farming that don't rely on soft soil? There's both no-till and low-till agriculture. These are all terms that the good kids already got out of their homework. I just wanted to show you pictures so you know what I was talking about. Something that was not in your book, though, strip and alley cropping. where some of the rows provide protection to the other rows. So like all the desks are strawberries, and in the pathways I plant corn. So when I harvest the strawberries, the corn protects the soil. And then when I harvest the strawberries, the corn stalks protect the soil.
You said the same thing twice.
You know what I mean?
Protects each other.
You like alternate harvest. So there's some rows that are going to anchor the dirt and provide wind protection while you're alternating with the other crop. Yes, these make sense, Eagle? Alley cropping is between rows of trees. Strip cropping is just alternating crops in rows. A little bit less efficient, but usually a pretty easy way to keep your soil where you want it. For all of you, erosion's like, it's not the Dust Bowl anymore. But just so you know, erosion globally is the single biggest threat to food. The number one problem for feeding humans in the future is that we're losing all of our dirt. Globally, we're losing something like 1/4 inch per year. If you're good at math, that's not good, because we live a lot of years. That's kind of severe, actually. Okay. Maybe we want to talk more erosion and more soils and stuff. Jason's the worst. Next, pests. Why don't we need pest control in natural ecosystems? Why, Emily?
Because they have like natural fertilizers and natural ways of like controlling the symbiosis between the pests.
Be more specific, and what's fertilizer got to do with it?
Well, I was gonna say like because the crops like rotate, so the pests don't have time to like them.
In nature, crops rotate? Yes.
Because there's different types of like plants that not all bugs like the bug will only like one certain plant, but if there's only one of them, like 10 other different plants, they can't multiply as fast as when there's like miles of that same crop.
Okay, so the pest populations grow more slowly in nature. That's probably true. What else? Yes.
You can use like natural insects to eat other insects like ladybugs.
I'm in nature. I don't want to use nothing. Yes.
There's a large variety of plants.
What else? Yes.
Well, maybe I don't know if it's next, but like since the plants are kind of competing with one another, then the insects that kind of go with it.
That might be true. What else is there in nature that keeps insect populations from exploding? Yeah.
Succession.
I don't know how that would. No.
A greater variety
Of what?
of plants.
Like in our hills, why don't we have like pest problems? What would happen if there was a whole bunch of like locusts out there?
Well, are they like eat all of their other predators?
There's other stuff that'll eat them.
Yeah.
Food webs are dynamic. You know that food webs go back and forth. If you've got a lot of bugs that are eating some of the plants, maybe the plants will outcompete each other and those bugs will disappear because they've run out of food. Maybe some birds will enjoy the feast of locusts and hammer the locust population, right? Because ecosystems are diverse, they are resilient, and because they are resilient, usually big changes don't happen. Not agriculture. Agriculture is an artificially simplified ecosystem. You get rid of the trees, so you get rid of the birds, and you get rid of all the other plants, so now when the locust moves in, you lose all your broccoli because there's nothing else going on. Understand what I'm saying by this? And so as long as we've had agriculture, we've had bug problems. Bug problems are unnatural. Bug problems are what you get when you oversimplify an ecosystem. You've lost some of those natural population checks and balances. Does that make sense to everybody? You know what I mean by that? Do you know that in parts of the world, deer are a pest? Because, you know, there's no wolves and there's no other competitor herbivores, and so now deer just kind of take off. When you simplify systems, things get kind of cattywampus.
Is it predator effect?
Yeah, sort of like a predator effect, exactly. So, as long as we've grown food, we've had some sort of pesticide to deal with that unnatural circumstance. Pesticide is just a part of farming. And I want you to know 4 phases of pesticide because things have really changed and not all pesticides are the same. Number 1, we used to use just toxic elements like arsenic, cyanide, and that works, that kills everything. It's very broad spectrum, including the humans that eat those plants. So you had to really wash the plants very carefully and make sure that you didn't eat the wrong part. People get very sick. I'm on number 19, and there have been 4 phases, and the first one was just toxic elements. And then the second phase was like simple chemistry. We used to basically use petroleum products like oils. And again, kind of broad spectrum, not very specific, not highly effective. The glory days was after World War II. You might know that the Second World War really fueled the global chemical companies. Have you all heard about that? The Second World War was sort of like the launching point for modern chemistry. Yeah.
Was the Green Revolution, right? Was that time?
Same timing, yeah, same sort of stuff, yeah. We got really good at chemistry around the 40s and the 50s. So we developed the key terms you have to know, a few important words. Synthetic, organic compounds. What do I mean by organic? Is that like the strawberries that you pay more money for at farmer's market? What do I mean by organic?
Natural, grown.
No. What's organic chemistry?
Not genetically modified.
Definitely not. Don't write these things down. Anybody know what OChem is? Chemistry based on carbon. An organic compound is a carbon compound. You have to know that. That's very important. In this case, organic means carbon-based. This is a key distinction. It comes up all year. Put 3 stars next to it. Organic compounds are compounds that are built around a carbon atom. That carbon atom is important. First of all, carbon's really strong, so those compounds are, write it down, stable. Once you stick things to carbon, they pretty much stay stuck. You know, carbon bonds are strong. That's why sugar is important, because it holds a lot of energy. You understand that? Carbon bonds are strong. Number 2, it's kind of easy to build those things. In a scientific laboratory, you can really manipulate carbon compounds. You can invent carbon compounds that do whatever you want. So if you want to target the so-and-so metabolic pathway, you just make the carbon chemistry that will disrupt that compound. Carbon's easy to work with. You know, like Duplo or like the big Legos for the little children. Carbon is like the most introductory type of synthetic chemistry. You can pretty much make whatever you want with carbon. It's very easy to work with. And the final key distinction about organic chemicals, your cells are stupid. Your cells don't know better. In nature, do you all know the only things that are carbon compounds? Sugars and carbohydrates. Guess what? Those are really rare in the evolutionary landscape, so your cells love carbon. They're not smart. Your cells evolved a long time ago. So when your cells see carbon, they're not like hip to modern pesticide trends. Your cells are simple and stupid. So your cells go, ooh, carbon, sweet. And they just absorb stuff that has carbon. Here's a fun fact. I'll tell you more about this later. You don't have to write it down yet. You can eat all the mercury you want, it's fine. as long as it's raw elemental mercury, like that kind, Hg, just plain old mercury, go ahead, drink up, no problem. It'll just go clink and you'll crap it out in the toilet, no big deal. Problem is, most mercury is stuck to carbon atoms. And your cells go, ooh, carbon! And they absorb all that mercury, and then you get mercury poisoning in 13 places, which are all right around there. That carbon issue is a big deal. We're talking about pesticides in number 19. The third phase, the glory days of chemistry, 40s, 50s, and 60s, gave us the rise of the final vocab term, persistent organic pollutants, POPs, P-O-Ps. Persistent organic pollutants. Key term in environmental science. They are chemicals we made using carbon because it was easy, because it's sturdy, and once we put those things in the environment, they will never go away. We made poisons that are going to be with us forever. All the DDT that was ever made is still out there bouncing around the food webs of the world. Just bloop, 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 bloop. Sooner or later it gets into you. When you die, it goes into something else. Bloop, 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 bloop. Persistent, like they last forever. Organic, like they're built out of carbon. Pollutants, like they're something which is bad for us. DDT is a perfect example. DDT is a great pesticide. It's really good at killing bugs. It's custom-made chemicals for killing bugs. Nice. Problem is, every life form on Earth goes, ooh, carbon, and soaks it up. So it gets into the algae, then it gets into the bugs, then it gets into the fish, then it gets into the birds. Did you all hear about those birds that would sit on their eggs and their eggs would be too squishy? Because the DDT sort of disrupts the bonding of calcium and carbonate. So they make weak shells and the birds all crap, their eggs explode. Heard about this? Bald eagles on Channel Islands? Pelicans all up and down the coast? Osprey almost went extinct? Okay. DDT gets into all sorts of cells because the cells are like, ooh, carbon, I'm a stupid cell. And so they just absorb it and then just keeps traveling up the food web until it reaches critical mass at the top of the food web where you've gathered all that energy. So, fourth wave of pesticide, we got smart. Modern pesticides are pretty different, and I'm not like really into pesticide. I'm not a fan of pesticide. Just so that we're clear, pesticide is fine in your food supply for you when you eat the food. There's no evidence that pesticides are bad for you as a food item. Because they don't end up in your food item. If you drink pesticide or eat pesticide, that's very bad. So you know who pesticide is bad for? The ecosystems around the farm and the people who work in the farm or the people who live right next door to the farm, they're all screwed. By the time the tomato shows up at Vaughn's, there's really no pesticides left. You can eat that tomato. We've used pesticides to make food for a very, very, very long time. There is no health consequence of eating conventional foods. Everybody thinks that they're saving the planet by eating organic, and they are. Everybody thinks that they're saving themselves by eating organic, and they're not. You're just spending more money for food that tastes better and saves the planet, but it's got no difference for you.
Compared to what?
Conventional foods.
What is conventional food?
If this tomato is grown with pesticides, and this is an organic tomato, they're both equally healthy for me. The one that was grown with pesticides was bad for her community, her ecosystem, the bugs and birds around there, the workers on that farm, the water that runs off that farm. So pesticides are bad, but not for the consumer of the food at the end of the day. Yeah.
So in this article it says pesticides might cause an extra 4 million cancer cases among Americans, and that's not necessarily like
From the
commoners eating it, but like
Right.
other people.
Right. So environmentally they cause cancer to people around them and the people who drink that water or whatever.
Like from that video with this.
Like that.
Okay.
Pesticides are really, really, really bad. Just not for the person who eats the food at the supermarket. It just doesn't get to you. Anyway, The distinction I wanted to make is modern pesticides in the fourth step in number 19, like the final phase, the modern phase of pesticides, we've made them very specific, and usually they self-destruct. So it kills just the bug you want to kill today, and by tomorrow, the day after, it doesn't exist anymore. The chemicals break apart.
It's good. It's good.
Yeah, I mean, I'm not like crazy about pesticides. I don't like support pesticides. They're horrible in some types of issues. But unlike DDT, like all the DDT that was made in 1950 is still knocking around somewhere.
Is there any way to get rid of it?
Not really. I mean, we could like atomically chelate the earth, but this is pretty difficult. There's like ways to find chemicals and like pull them out of solutions, but basically you would need like a really expensive and slow filter for the earth.
For the most part.
Probably. I mean, arguably the best way if you want to get into like extreme planetary manipulation would be to kill all of the predators and like bury them in silos or something. Like, that would work. Pretty sweet. The things I wanted to remind you of, really simple, slightly more complicated. Holy crap, the persistent organic pollution era. And now we're in the era of modern pesticides, which are still bad for some issues, but not bad for the consumer. And they are less harmful than the 50s, 60s, and 70s because they self-destruct. They're not persistent. But what about the hippies? What did the hippies do? If you're not going to use pesticide, how are you going to get rid of your bugs? Because you know bugs are going to show up when you simplify ecosystems. Yeah?
Crop rotation.
Yes, that's one thing. Yes?
Biological control.
Biological controls. What else? You can use different watering. Like you water at a different time or in a different way. Like when you change the water supply, a lot of bugs go down. You can use airflow, like air circulation. Yes?
You can use like other organisms that act as like a natural.
This is what we mean by biological control.
Oh,
That's
okay.
that's what
Like
biological.
the ladybugs or even the other pests.
That's a biological control, yeah. And how about this? You can provide habitat for the beneficial organisms. It's called insectary planting, where you give a place to live for the predatory bugs. What is the combination of all of these ingredients? It is number 20, integrated pest management. IPM, integrated pest management. IPM. Integrated pest management, IPM. It is the combination of crop rotation, irrigation methods, airflow, biological controls. Oh, and by the way, I should mention that IPM does allow for chemical use. It's just kind of like the last resort. Tim, it was just announced that they are postponing the trip until November 16th. I'm guessing bad weather.
Stardust trip? Oh, yeah.
I'm guessing bad weather. So hold on to your application. Sorry about that. I just got a message right here
From what? From Donnie?
from 1 minute ago from Elena Khan. They've decided not to go out. The weather looks gnarly.
Yeah.
Okay. Integrated pest management is done. We've got like 2 concepts and then we're done for the day. We are going to finish on time. Number 21. Why are people so freaked out about genetically modified crops? What is the fear? Yeah.
Super hybrids can produce that can grow when they're not wanted and become pests to other things.
Yeah, so basically the loss of control. What else?
They can become resistant to chemicals and pesticides and just become like a super plant that
Yeah, that loss of control, the plants spreading where you don't want them. Super weeds. What else? There's a couple of more general issues that are kind of tough to explain. I've got 4. Yeah. Yeah, so this is one of them. One of our fears, probably the biggest, is called genetic contamination. The idea that genes might spread. How does that happen? Well, there's a common, reasonable and simple example, and then there's a much more theoretical but possible issue. So the common issue is, like, pollen travels in the wind. So modified genes from corn have been found in corn plants thousands of miles away from genetically modified farms. So like Oaxaca, which is like the heart of historical corn cultivation, it's southern Mexico, like highland southern Mexico, tropical Mexico. There's like strains of corn back there that go back like a gazillion years, of like little pygmy corn and multicolored corn and hard corns and soft corns and popcorns and all these crazy kinds of corn. The southern Mexicans, before it was Mexico, made like crazy different types of corn. Just selective breeding, right? People went down there, analyzed corn about a decade ago, and they found that there was already contamination of genes that had traveled through pollen all the way from North America. So genetic contamination.
And that would just eventually wipe out the native species?
It just kind of homogenizes them. So you lose what makes those special because they've just kind of blended with other genes.
And it's just negative because it just kind of ruins the ancestry, or
Maybe, yeah.
potentially
Yeah,
actually?
it sort of like takes away what makes them unique, perhaps. So you've lost your reservoir of diversity, and diversity is always helpful in the end. The separate issue is, what if it gives them traits we don't want? Like, what if wild corn becomes toxic to bugs?
Why is that bad?
Because they might depend on their bees for honey production on that farm.
And, okay.
Or they might lose their native pollinators, which are useful for other native plants. Then there's the theoretical one. There are viruses that move genes between organisms.
Does that only go for plants?
I don't understand these things very well.
Kind of scary.
There is evidence that genes travel between organisms, between species. Because of some, I think it's retroviral activity. I don't understand, I'm not smart. I'll bet you the bio teachers know the terms. I learned this in college and it just kind of I lost it. So the genetic contamination is a problem. Here's an interesting solution that itself makes a problem, and this is the part where my students are like, just too much crap, I'm going to skip this one. But try to hold out for me. To prevent genetic contamination, scientists have made what's called a terminator gene. Does anyone know what terminator gene is? What is it?
You're gonna make certain genes sterile so they can't be transferred.
It makes seeds sterile. So you make a plant which makes seeds that work, but in the next generation, those seeds won't work. Terminator gene. It's like a self-destruct for the genetic material. Why would the seed companies want to make seeds whose offspring seeds are sterile?
So they can have a monopoly on the seeds.
That's right, so they can sell you your next round of seeds. Does everybody understand that many farmers keep their seeds?
Yeah.
Watch me. But this is kind of like Introduction to Farming 101. We've got just enough time to make this additional input for you. What? I take my corn seed, I put it in the ground, corn grows. Corn is just a bunch of corn seeds. You eat some of them and you save some of them for next year. It's called seed saving. Most farmers save their seeds. But if I'm going to buy your fancy corn product, put it in the ground, and then keep my own seeds, you're out of business. So the Terminator gene was a way to prevent people from saving their own seeds. Make sense? Perfectly legal practice for seed manufacturers. What if the Terminator gene spreads to other varieties? That people can't save their seeds, and globally most food production is small scale, is made by, most people are fed by seeds they save themselves. So this is like a big impact for like social justice and like subsistence farmers all over the world. Okay. Then there's two more issues that I think are the ones that are probably most relevant to you. We've had very limited health testing. I mean, we've done one extremely big health test. Anybody know what that is? All of us right now. Basically, genetically modified foods became our food stream under the assumption that it must be a normal food item. But we never really tested anything. So people got really nervous about like, what if she's allergic to peanuts and there is like a peanut protein in her corn and she has an allergic reaction? Never happened, so maybe it wasn't a big deal. But the lack of testing was a big scare for people. And generally speaking, the unintended consequences, where we always try to change something in nature and then it has like surprising outcomes, that always scares me. Like, I'm just afraid we're gonna find out we broke it later. Hey guys, look, I made it. Oh dang, I broke it. That's like so much of environmental science. It's like, oh look, hey everybody, look, I got a solution, and it was like, oh dang, this broke. Just so you know, we are basically one of the only countries where the federal government thought if our genetically modified foods were labeled, we would make stupid decisions and eat less fruits and vegetables. So to save us from ourselves, the feds won't let us have labeled genetic ingredients, genetic modified ingredients. Yeah?
Isn't there like a coating on those little stickers that tell you whether it's GMO or not?
I guess that there's a coating that tells you if it's organic or not, and organic by definition is not GMO. There was like a meme on the internet that said that one of those prefixes was
It's like 452.
whatever that number was, but I'm not convinced that's what it means. I've only seen that on Facebook. I've never actually like seen that anywhere else. So
I
don't know if
looked
I
on
trust
all
that.
the labels and they had all those prefixes.
The prefixes exist.
Okay.
I just don't know that that combination tells you it's GMO free. All right. If nobody has GMO questions, I have just one thing left. Bueller, anyone? Okay. Oh yeah, what?
Can I ask one about 17? What is the difference between young and mature soil composition and how does grain size affect soils composition?
So younger soils tend to have a lot less organic material and a lot less complexity. If you have a diversity of grain sizes,
Your
you,
soils have less what?
organic material and less nutrient complexity. And if you have a variety of sizes, of grain sizes, then you tend to support more diversity and more balanced nutrient profile. Your book also has a thing about how like the clay is really good at holding ions and water or something, and silt is really good at something, and salt and sand is really good for drainage because water goes through the gaps or something, but I forget that thing. So the last thing I want to do is number 23. And first and foremost, and number 24, I want to make sure everybody writes down somewhere in 23 or 24, write it down very, very large. Desertification does not equal erosion. They're not the same thing. First, the easy part, what is erosion? What is erosion? Yes?
Loss of soil where you need it.
Correct. It is plain old, erosion is easy, soil loss. What's desertification? Yeah, bingo. It is the loss of soil quality. And these things are tied together often, but they are not the same thing. I just discovered that my previous slide had a typo in it about this topic. For years I have confused my students because these things are tied together, so this year we're going to get it right. Erosion is the loss of soil. Desertification is the loss of soil quality. Does everybody know that grazing is when animals eat plant? So how can you overgraze? What is overgrazing? Like the cow got a bloated belly because it ate too much grass, and the cow is fat because it overate? No.
Not letting the plants grow back.
Not letting the plants
Having
grow back?
too many animals for the area.
Kinda, yeah.
Yeah, it's when you have like too many animals and then because of like their hooves and the soil, like it compacts the soil. and
Kinda.
They don't have any more food.
Here's the key distinction that a lot of my students fail to consider in this issue, and it's basic biology that you all know, but none of you said it, and I'll bet you none of you would have put it on the test until now you're going to get it right. There's the plant above ground and the plant below ground. If you look at grass, there's like green leaves and white roots. Those leaves have a purpose. Why does plant have green stuff? Photosynthesis, which is the production of sugars, which are used to store. And so plants need some green so that they can metabolize and grow, right? Here's the fun fact. You see, you might not remember that we used to have grass back in the day. And back when we had grass, please look up, if your grass is this long and you cut half of it, it grows right back because it's got some energy production plants left over for doing more growth. Agreed? If your cattle eat all the way down to soil level, you've left no energy source for the plant. It has to struggle to barely build a little tiny bit of solar panel, to build a little tiny bit of energy, to do a little tiny bit of growth. And that like first couple of inches growing out of the dirt, that takes a long time. That's what overgrazing is. If you just give the grass a haircut, it's like, all right, guys, we got this. The plant will just keep on growing. But if you hammer it all the way down to soil level, it won't come back very well. And even worse, if you go below soil level and start eating the roots, you've completely killed the organism. It will not, you'll have to wait for seeds to make something new. That's what overgrazing is. When the future growth of the plant is sacrificed. Does this make reasonable for everybody? These make sense? So all you gotta do is move the animals before the grass gets too low. Please look up. Seasonal grazing is not good. If you just leave the animals out there for a block of time instead of watching the vegetation, that's bad. I tell you a story, this makes sense later. The other day I was on my boat with my homie, and I was like, hey Jesse, will you drive? I gotta do some blah blah blah. And so I'm doing some blah blah blah, and he's like driving. He's like, hey man, you think I can go faster? I'm like, oh bro, just punch it. Drive it like you stole it. Pretend it's a rental. Oh, hold on, I gotta do this. Most ranchers rent their land. They're not on their own land. So they just use up all the vegetation and then they move along. And then the land won't recover and you lose soil quality. When it gets all sandy and crabby with no organic material, that leads to erosion. This is the connection. Desertification is the loss of quality which leads to erosion.
So desertification is not necessarily the build of a facility,
No.
but it can be.
part of it losing quality, yeah.